For loops. In this video, we will learn how to execute statements a predetermined number of times. In the previous video, we defined a while loop as a body of statements that executes repeatedly until the looping condition becomes false. This is great for applications where we don't know beforehand how many times exactly we'll need certain code to be repeated. For example, the password checker. We don't know beforehand how many attempts it'll take for the user to guess the correct password. So we just tell the code to repeat until the user guesses correctly. But what about applications where we do know exactly how many times we want code to be repeated? For example, suppose I want to write a program that'll press play on every single song in a musical playlist. In that case, I know that the number of times I need the code to be repeated will be equal to the number of songs I have on that playlist. For example, if the playlist has 10 songs, then I'll need the code repeated 10 times. If the playlist has 25 songs, then I'll need the code repeated 25 times, so on and so forth. For an application like this, it would be best to use a for loop, which is a body of statements that executes a predetermined number of times. So, how do I write a for loop? Let's look at an example. Okay? So, the first line of a for loop will begin with the keyword for, followed by I, which is simply the name of the loop variable. This variable will come in handy, but we're not going to focus on it right now. We'll talk about it more later in the video. Just know that I is simply the name of the loop variable. Next, you have the keyword in. Now, in is not a variable, it's not a value, it's just syntax. It's just a part of the for loop syntax, and there's nothing more beyond that. Now, the most important part of this line is the use of the range method. This is where we state how many times we want the code to be repeated. So in this case, we gave the range method the number 5. So that means any statement we put in the for loop will get executed 5 times. So suppose on the next line, I indent one level and print hello world. Once again, notice that I indented this code. Without the indentation, the Python interpreter will not interpret this line as a part of the for loop. Since I indented it, it will be seen as part of the for loop, and thus it'll get executed 5 times. Thus, the output of our program will be the string hello world 5 times. Now, in this example, we gave the range method a number. It's worth noting that we could have also given the range method a variable that stores a number. We also could have given it an expression that evaluates to a number. Anything that evaluates to a number, whether it's a value, a variable, or an arithmetic expression, Python will allow you to pass that to the range method. Now, let's go back to our original example, and now let's switch our focus to the loop variable. The loop variable can be useful in a lot of ways, and here's how. Suppose in the body of the for loop, I print out the variable. This would be the output of my program, 0, 1, 2, 3, and 4. I could also print out the variable as part of a string, okay? Here I print it out next to hello world. Also notice that I use the str method to convert I to a string. Otherwise, Python will not allow me to concatenate I onto the string. So when I execute this code, this will be my output. So what exactly is happening here? What's happening is that range 5 is storing the values 0, 1, 2, 3, and 4 inside the loop variable. More specifically, it stores 0 during the first iteration of the for loop, it stores 1 during the second iteration, 2 during the third iteration, 3 during the fourth iteration, and 4 during the fifth and final iteration of the for loop. To illustrate this point further, suppose I replace 5 with 10. Well, in this case, the values 0 through 9 will get stored inside the loop variable, and when I print it out, this will be my output. So, in summary, anytime you give a single number to the range method, the values 0 up to but not including that number will get stored inside the loop variable during each iteration of the for loop. Now, suppose you don't want to start at 0. Suppose you want to start at 1 instead, which is pretty common. Okay, no problem. In that case, instead of printing out I'll just print I plus 1. That way, we're still storing the values 0 through 9 inside the variable. However, when it comes to printing, we're printing 1 above what's in the variable. Now, let's say you don't want to start at 0 or 1. Let's say you have a specific range of values that you want to use. For example, 5 through 13. Well, in this case, we're going to give the range method two numbers. We're going to give the range method our starting point, which is 5, and we're going to give it an end point, which will be 1 above the last number we want to use, which is 13. So in this case, we're going to give the range method 5 and 14 as the values. Thus, in my for loop body, when I print out the variable, this will be our output, the numbers 5 through 13. Notice once again, 14 didn't get printed out. 14 never gets stored inside the variable. 14 is the stopping point. Now, before I move forward, I need to point out something that each of the examples we've looked at so far all have in common, which is the fact that in every example, the loop variable increases by 1. That is the default change for the range method, but it is not the only change the range method can do. For example, if I want the loop variable to change by 2 after each iteration, I will do that by giving the range method a third number. All right, I'm going to type 2 for the third value, indicating that I want the increase to be by 2 after each iteration. Thus, when I print out the variable in the loop body, this will be my output, 5, 7, 9, 11, and 13. Notice that the variable is increasing by 2 after each iteration. Similarly, if I type in 3 for the third value, then the loop variable will increase by 3 after each iteration. Thus, when I print it out, my output will be 5, 8, and 11. Notice that 14 didn't get printed out because even though 14 is 3 above 11, 14 was written as my stopping point. Thus, 14 is not included in the list of values that'll get stored inside the loop variable. Okay. It's also possible to go in decreasing order. For example, suppose I want to print the first 10 positive integers, but I want to print them in decreasing order. In that case, my starting point will be 10, my end point, my stopping point will be 0, and for the third value, the change, I want it to be -1. I put -1 because I want to decrease by 1, not increase. Thus, when I print the I variable in the next line, this will be my output, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And once again, notice that 0 did not get printed out because 0 is my stopping point. 0 is not included in the list of numbers that'll get stored inside the I variable. We'll close this video by demonstrating how the for loop can be used to execute a very common real-world application, the running total algorithm. Let's say, for instance, I want to compute the sum of the first 10 positive integers. Okay? One way to do that would be to declare a variable named sum and simply set equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Then on the next line, I'll print that variable out, thus giving me 55 as my output. That would be the correct output, however, it's pretty tedious. What if I wanted to know the sum of the first 100 positive integers, or the sum of the first 1,000 positive integers, or 10,000? Now the program is becoming extremely tedious. A much simpler way to do this would be to use a for loop, where the numbers I want added will get stored inside the loop variable. Here's what I mean. In this case, I'm going to declare the variable sum once again, but I'm going to start it off at 0. Then in the next line, I'm going to declare a for loop and tell it to start at 1 and end at 11. Once again, 11 is a stopping point, so 11 won't be included. Then inside the for loop body, I'm going to increase the sum variable by the variable I, which means in the first iteration, sum will get increased by 1, then it'll get increased by 2, then it'll get increased by 3, so on and so forth. Sidebar. This statement is not the same as me simply writing sum equals I. In this example, I'm replacing the sum value with I. So in the first iteration, sum will get replaced with 1, then it'll get replaced with 2, then it'll get replaced with 3, so on and so forth. That's not what we want. We don't want to replace the sum variable with I. We want to increase the sum variable by I. We want to add I to the variable. So we're going to need to write sum equals sum plus I because that's how you increase the variable by that amount. So after executing the for loop, we'll then print out the sum, and for our output, we'll get 55. The beauty of this approach is that if I wanted to, for example, compute the sum of the first 100 positive integers, then I would just need to change 11 to 101. If I want to compute the sum of the first 1,000 integers, I will just need to replace 11 with 1,001. In either case, the point is that no matter how large a number I use, the for loop enables me to keep the program short and simple.